Hey guys, welcome to Chapter 2, 2426 Test Corrections video. Remember, in order to get test corrections or your percentage back, you need to have this form filled out correctly. We need to have the original problem written here, not just the number. The number can go up here, but the original problem, what actually the problem is asking us to do. The correct answer, not the letter, the actual answer, with an explanation of why this is the correct answer. So there should be a lot filled into this little box right here. The correct answer, not the letter, the answer. And then the reason why that is the correct answer. What was your mistake? Which answer did you pick and why did you pick it? Can go down here, the what went wrong. So you can put your mistake and why you picked it, and then the what went wrong down here. The who helped you, did you get it from the video or did you get it from a private tutor? And the error code. Your error code comes from up here. Your original test answer sheet needs to be attached and it needs to be signed, and your parent needs to sign that form, or sorry, that answer sheet and this form right here. All of this has to be done in order for you to get a percentage back on every problem. Okay, let's get started. Number 6. What is the solution to the linear absolute value equation? A lot of you guys are still having a hard time on how to solve an absolute value equation. What you need to do is you first take that equation and you set it to two different answers. The first answer is positive and the second answer is negative. So negative x plus 18 equals 7, or negative x plus 18 equals a negative 7. Remember when we did this, we could have two possible answers. It could be positive 7 or it could be negative 7. All right, so let's go ahead and solve it out. What I'm going to do is subtract 18 from all sides. And then over here, I get a negative x equals a negative 11. And then or over here, negative x equals a negative 25. But I'm not completely done. You can't have a negative sign in front of your x. So whenever we have a negative sign in front of our x, we could divide both sides by a negative 1, because that gets rid of the signs. Or you can think about just changing all the signs. So this would cancel, and that leaves me with x equals 11, or x equals 25. So when I go and I look up at all my numbers up here, I need 11 and a 25. So right here at D, x equals 11 or 25 would be my answer. What is the solution to the compound inequality 85 less than or equal to 17m less than or equal to 136? To solve this one, this is in compact form, I'm going to go ahead and write it out. 85 less than 17 times m less than or equal to 136. Now to solve this, I need to get that m by himself. Well, ask yourself, what operation is going on? This is multiplication. How do we undo multiplication? We undo multiplication with division. So if I divide this product right here by 17, I have to divide all parts by 17. So that means 85 divided by 17 and 136 divided by 17. And if I do that, 85 divided by 17 gives me 5. 5 less than or equal to, those would cancel, which is the whole point, less than m, less than or equal to 8. 136 divided by 17 is 8. Now when I go look up here, notice none of them are written in compact form, but you can already eliminate some of these choices. This is written in compact form, and since it's in compact form, I know it's an and inequality. It's an and compound inequality. So right away, A is not an option and C is not an option because it has the word or there. So I know I'm between B and D. I just have to make sure the alligator is eating the right letter or the right number. So let's take this first part. And I'm going to go ahead and write that 5 is less than or equal to m, and then I'm going to write the word and because it's a compact, and then I'm going to write m again is less than or equal to 8. So I need to go and find that situation up at the top, and that would be letter B. Because look here, the alligator is eating the 5 here, so that would be incorrect. we need to use this one right here, letter B as our answer. Solve the linear absolute value equation. So we have 2 absolute value x minus 6 equals 48. So again, just like before, let's go ahead and isolate that absolute value. How do we do that? Well, we need to get rid of this 2, and you cannot distribute it in. This is multiplication, so how do we undo multiplication? With division, so we're going to divide both sides by 2. That leaves me with absolute value x minus 6 equals 24. And then now to solve an absolute value, you've got to split into 2 equations. Our first equation is going to be x minus 6 equals a positive 24, or x minus 6 equals a negative 24, because we could have 2 answers, a positive or a negative answer. Because I can put a negative 24 into here, and it would absolute value of negative 24 is also 24. All right, so let's go ahead and solve the equations. We're going to add 6 to all sides. Notice that our signs don't change here. Those are the same. They're always going to stay exactly what we had in here when it comes out here. The only thing that changes is your answer. All right, so we've got x equals 30 or x equals negative 18. All right, so we're going to look up here. I need a 30 or a negative 18, which is letter A. Determine the number of solutions for this situation. Well, it's an equals. And equals is only going to have one solution, and it's the solution that he's equal to. So our answer should be C. Solve the equation. If there is no solution, write no solution. Let's go ahead and solve this one. 2 absolute value n minus 12 equals 16. So I'm going to add 12 to both sides. Remember, opposite, whenever we're solving, when we're solving for n, we do the opposite. We're not going to divide first. We're going to move this negative 12 over first, and then we're going to divide. Remember, it's kind of like the backwards version of PEMDAS. All right, so then I get 2 absolute value n equals 28, and then I'm going to divide both sides by 2. Because this is multiplication, and I undo multiplication with division. So I get the absolute value of n equals 14. And again, he's all by himself already, so this is actually pretty simple. I'm going to separate this into 2 equations. My first one is n equals a positive 14 or n equals a negative 14. And that answer would be letter A. Evaluate the expression, negative 8 times 7. So again, one of those situations where you have to think of what do we do first. Well, inside our absolute value, we have an operation that's multiplication. So we need to do negative 8 times 7. And negative 8 times 7 is a negative 56. But I still need to write those absolute value signs because I haven't done absolute value yet. Absolute value of a negative 56 is positive 56. So our answer for this one should be B. An inequality for the graph. So this is just a simple inequality, and it's going to be an and situation. So we're starting off with negative 8, and we can write it as less than x. It's a strictly less than because it's an open circle, so I know it's going to be strictly less than x, and then less than or equal to 11. And I know that because of the closed circle down here. So I have negative 8 less than x and less than or equal to 11. And let's see if that actually matches anything up here. So looking at letter A right off the bat, negative 8's match up. It's less than x, x. Less than or equal to 11, so it matches perfectly. So A should be my answer. Moving on. Solve the equation. If there is a solution, write no solution. So I've got absolute value x minus 7. So absolute value x minus 7 equals 6. I'm going to get it by itself first, so I'm going to add 7 to both sides. That gives me absolute value of x equals 13. And now to solve this, I need to set 2 equations up. X equals positive 13 or x equals negative 13. So there's were my 2 answers, and that would be letter B. Classify f of x equals negative 7x as linear, linear absolute value, quadratic, or an exponential. This is linear. because it's just an x, he doesn't have an exponent of a 2, or he's not in the exponent, and there isn't an absolute value. So it's definitely not absolute value. It's not quadratic because quadratic looks like this, and it's not exponential because exponential looks like that, and absolute value looks like that. So it's linear, so it should be A. Evaluate each absolute value. So again, this is just the absolute value of positive 3, which is positive 3. What is the value of the linear absolute value expression here? So this is that example, those examples that we were doing in class on what do we do first. Well, for this first one, for absolute value negative 15 minus absolute value 8 minus 14, for the first one, we don't have anything going on inside the absolute value, so we get to just do the absolute value. The absolute value of negative 15 is positive 15. And then we've got our minus sign. And then inside this one, we actually have an operation. So we need to subtract absolute value, and then 8 minus 14 is negative 6, so absolute value closed. I still write the absolute value signs because we haven't done that part yet. Now we can. What's the absolute value of negative 6? Well, that's 6. And then we need to bring down our minus sign, and then we need to bring down our 15. So we get 15 minus 6, which is equal to 9, which is letter C. Which compound inequality has no solution? So how to solve this problem is to go and graph all 4 of these. So let's graph the first one. If we draw a number line for A, we've got we've got negative 2, and then we've got a 0, and then we've got a 5, and on this side is 6, on this side is negative 3. So let's think about the number line for this one. So x is less than 5. So that would be an open circle, and we would shade to the left. Okay, and then for x is less than negative 2, that would be an open circle, and we would shade to the left. And since it's an and situation, it would be what they have in common, which is this part right here. So of all of that, this is our actual answer. So we do have a solution for letter A. All right, letter B, we have x is greater than 5. So we have 5 again. And then x is less than negative 4. So on 5, x is greater than 5 would be an open circle. And I'm going to shade to the right because it's greater than. And then for x is less than negative 4, again an open circle. And I need all the numbers less than negative 4. So that would be going further into the negatives. So that would be this way. Well, since this is an and problem, it has to be what they have in common. But they don't have anything in common. They don't overlap anywhere. So the actual answer to this one is no solution because they do not have something in common. And since that answer is no solution, that's the answer to our actual question. So letter B. Solve each linear absolute value equation. So another one. But this one is actually really nice. I don't even have to do anything. I should look at this right away and see it's an absolute value equals a negative, and there's no way that that can happen, so you should know right off the bat that that answer is C. Okay, so let's begin. Make sure you are looking at the right form test, please. All right, let's begin. Evaluate the function f of x equals 31.572 times x minus 17.741 at x equals 6.2. What we need to do with this value right here is plug it into this x, and when we do that, it's going to be multiplication. So 31.572 times 6.2 equals, or not equals, minus 17.741. And when we do that, 31.526 times 6.21 is 195.7464 minus 17.741. So be very careful how you're typing this into the calculator. You want to make sure you're typing all the decimals in correctly. And when we subtract that, we get 178.0054, which is letter A. Okay, number 32. Solve the inequality, then graph your solution. So this one, these are the tricky ones. These are the absolute value and the inequality. So they're really, really tough. All right, so let's first address what kind of inequality we have. We have a greater than inequality. Remember when I taught you greater than, you need to think of or. So great or. So we write exactly what we see without the absolute value, and then we write the or sign, and then we do the opposite of what we see. The opposite sign and an equality sign. All right, so let's write exactly what we see. We see D plus 2 is greater than or equal to 6, or D plus 2. We always write exactly what's inside of there. We never change that. And now we need to change the inequality sign, so less than or equal to, and we need to change the sign of our answer. So he's positive, so he changes to -6. And then now we go and solve it. Subtract 2 from all sides. So I get D is greater than or equal to, 4, or D is less than or equal to -8. So I'm going to go look at my -8, and I'm going to have a closed circle, and I'm going to be shading to the left. So I need a -8 and a closed circle. So that one's not right. I know that letter C is not right. And then I need a closed circle on -8, which is right here. These both have closed circles. That one's off, so I know that one's not the answer. So I'm -8 and I'm shading to the left. And then I need D to be greater than or equal to 4. So here I have D is greater than or equal to 4, so it's a closed circle and it's shaded to the right. I just need to have the signs match up. Look how this is a greater than. See how the alligator's eating the D? And the alligator's eating the -8 over here, so that's real tricky. Make sure that you didn't fall for that one. So that one's definitely not the answer because it's written wrong. That makes letter D my answer. Ideal width of a safety belt strap for a certain automobile is 5 centimeters. So in a perfect world, it's going to be 5 centimeters. So we already know that it says ideal weight. We already know that that's going to be in absolute value signs. And it's going to be a subtraction because we want to know what is the difference, which is why we have the difference, the subtraction sign. All right, then it says an actual width can vary by at most 0.35, which means it has to be within 0.35 and not over it, but inside of 0.35. So that's why we use less than or equal to 0.35. There's going to be a difference between the perfect world and what actually comes out, and that's why we do subtraction. And that difference has to be within 0.35. So our answer for this one should be letter D. Determine the number of solutions for each equation, then calculate the solution. So these were those sentences that we wrote down in our lesson packets. If an absolute value equals a positive number, then we have 2 solutions. So right off the bat, you know this is not an issue, this is not a solution, and that's not a solution. So right away from knowing that one sentence, you would have known A should be our answer. Because we could put a positive 15 inside the absolute value, and we would have gotten a 15. Sorry, there's a negative sign in there. Let me erase that. So absolute value of -15 equals 15, and then absolute value of -15 would be a positive 15, and the absolute value of positive 15 is 15. So in both cases, we still get 15, and that's why we have 2 solutions. Choose the function that represents each problem situation. A bathtub filled with 50 gallons of water is drained. The water drains at a rate of 5 gallons per minute. So right here, gallons per minute, that would be the amount of gallons is going to depend on the minutes. So that's their time. So here, this would be our dependent, and this would be our independent. And that information isn't important for the problem. It's just good to go back and refresh that. So let's talk about where our starting amount is. Well, we're starting with 50 gallons. So that means we're going to have 50 gallons in our actual tank. And then we are losing water. Water is draining out. So we're going to do minus at the rate it's draining out at. Well, it's draining out at 5 gallons per minute. Here's our rate. So our rate is always going to get the variable. So we have 5 times x, x representing how many minutes have passed. And then this is a function. It's a linear function. I know it's linear because it's draining at a constant rate. And so we have f of x equals the amount we're starting with minus how fast it's draining out times however many minutes have happened. So our answer should be letter A. Write a compound inequality for each situation. People with driver's license are at least 16 years old. We've talked about that at least before. That is our greater than or equal to. And then keep reading. And no older than 85 years. So they've got to be less than or equal to 85 years by saying no more than or no older than. All right, so let's start off with saying x has to be greater than or equal to 16 and x has to be less than or equal to 85 because it's no older than 85. And if we look down here, we see that nothing really matches it right off the bat. Well, we know or is not going to be used there because this is an and situation. It can be written in compact form. And if I look at letter B, x is less than 16, well, we know that that one's not a situation either, so we're going to cross that one off. So let's go and look at the remaining two. Well, they're written in compact form, which means I need to translate this one into compact form. So start with the smaller number, which is 16, and then we have this sign right here. So I know that my alligator is going to be eating the x, so I'm going to flip it around, x, and then over here I have less than or equal to 85. And so the one that matches that is letter D. Solve the absolute value equation, so another one. I'm going to go ahead and separate him. I don't need to isolate the absolute value. He's already by himself. So let's go ahead and separate. 2x minus 5 equals 7, or 2x minus 5 equals a negative 7. And let's go ahead and solve. Remember, we're going to add or subtract first before we multiply or divide. So add or subtract, and that gives me 2x equals 12. 2x equals negative 2. And now I'm going to divide by 2 on all sides because everything's the same. And I get x equals 6 or x equals negative 1. And when I go up here, I see negative 1 and 6, which is letter A. Determine the number of solutions for absolute value x equals 0. Well, 0 cannot have a positive or a negative answer. So this one is going to be one solution, and it's x equals 0. So that was supposed to be a little tricky for you guys. Remember, that came from that section where we did those 3 sentences. Choose the function that represents each problem situation. A pasta company is filling boxes with pasta sold by weight. Each box should contain 16 ounces of pasta. The specifications allow for a difference of 0.5. So in a perfect world, every box of pasta would have 16 ounces of pasta in it. But things aren't always perfect, and that's why we allow for specifications of 0.5 ounces. So here we could have over by 0.5 and we could have under by 0.5. And if we were under, then it would be a negative situation. And so we need to make that negative number positive, and that's why we'd use the absolute value function. So for this one, we're going to be using this function right here. X represents what the actual box weighed, the actual weight of the box. And then minusing 16 is showing us how much it was off by. In the perfect world, it would all weigh 16 ounces, but it's not going to always happen that way. So that's why we have X, the actual weight of the box, minus 16, and it's allowing for a difference of 0.5. Well, the 0.5 doesn't happen into this problem because that would be if we actually wanted to solve it. We would do an X minus 16 is less than or equal to 0.5. It would be an absolute value situation because we could be over or under. All right, evaluate the expression 4 minus 12. So we have, again, absolute value signs, and inside of that is a 4 minus 12. So what do we do first? Do we do the absolute value or do we do the subtraction? We do the subtraction because he's inside. And then we do 4 minus 12, which is negative 8. And then we have the absolute value of negative 8, which is 8. So hopefully you got A for the answer. Negative 4 raised to the x. look at where our x is. Our x is in the exponent. And when our x is in the exponent, then we have an exponential function. So letter D. Evaluate each absolute value. Well, this one is just asking for the absolute value of negative 3.7, which would be positive 3.7. What is the value of the linear absolute value expression? So more stuff. Except this time we've got a lot going on inside of there, so you really have to know your order of operations. So inside the absolute value, we have a fraction bar, which represents division. And even inside that division, we have an addition in the numerator. So the very first thing we have to actually do in all three things, because we've got absolute value, division, and addition. The first thing we need to do is the addition. So I do negative 17 plus 8, which is a negative 9 over 4. Absolute value of that. And looking at my answers, I can see that they left it in this improper form because 4 doesn't completely go into negative 9. So they're leaving it in this form, so I don't really have to worry about the division. All I have to worry about is the absolute value. Well, what is the absolute value of negative 9 over 4? That just means it's positive because it's its distance from 0. And so our answer should be letter B. Solve the inequality, then graph your solution. So very similar to what we just did, except it's a less than sign. And remember, whenever we have less than, I wanted you guys thinking of it as a less than. We need to do and, which means we need to write it in compact form. And when we write something in compact form, we do small, or in this case, we're going to do the negative number, less than, x, or whatever the absolute value is, but without the absolute value signs, less than the big, or in this case, the positive number. All right, so let's look over here. We've got 25. So the negative number of 25 is negative 25. And then we're going to do a less than sign, and it's strictly less than because it doesn't have an or equal to. So strictly less than. And then we write everything we see inside the absolute value, but without the absolute value signs, because this is how we solve it. This is how you get rid of it, by writing it in compact form. And then we write less than, and then it's the positive number here, which is 25. Now I go and solve it just like I do an equation. I need to move this 9, so I'm going to subtract 9 from all three sides, because that would get rid of it. And then negative 25 minus 9 is negative 34. Less than 2x, less than 14. Oh, sorry, not 14, 16. And then I'm going to see what's left to do. I need to divide by 2 because this is multiplication, and I undo multiplication with division. So all three sides get divided by 2. So negative 34 divided by 2 is a negative 17, less than x, less than 8. So I have compact form, negative 17, less than x, less than 8, and that looks like right here, right off the bat. I don't even need to look anymore. I can see that this matches it perfectly. Just make sure that the graph actually does. Open circle on negative 17, open circle on 8, and I'm shaded in between there. So that should be our answer, letter B. Write a compound inequality for the flowers in the garden are 6 inches tall, 6 inches or taller, or shorter than 3 inches. So we have a compound inequality, and we're using the word or. Since we have the word or, we know compact is not an option. So it can't be the A and it can't be B. So it's going to be somewhere between C and D. I just need to figure out which one is right. So the flowers are 6 inches or taller. So they're allowed to be 6 inches. So I would say X is equal to, the half equal to 6 or taller, which means this is the smallest he's going to be. So if that's the smallest the flowers are going to be, then it's going to be greater than. So X is greater than or equal to 6, or they're going to be shorter than 3 inches. And it specifically says shorter than, which means it can't be equal to 3. So, or X is less than 3, not less than or equal to. So our solution should be letter C. Write each compound inequality in compact form. So So compact form means this, this, or this. So we automatically know that this is not an option. That's not in compact form. So let's look at what our actual problem is. It says all numbers less than or equal to 22. So all numbers is x less than or equal to 22. And at the same time, x has to be greater than -4. So remember, when we're writing something in compact form, we start with the smaller number first. So smaller number, small number, and then less than or equal to, depending on the situation, x, less than or equal to, depending on the situation, the larger number. So these all depend on the situation. So let's talk about our situation. We have -4 is our small number, so that's the guy who leads us off. And looking at it, it was strictly less than x. So -4 is less than x. So if I rewrite this as -4 in the front, that would be -4 less than x. See how that's less than sign? So then I'm going to go ahead and write -4 less than x. And then looking up here, I can just write it exactly how I see it, which is x is less than or equal to 22. And when I go and find that one, that is letter B. All right, number 29. We have determined the number of solutions for -x equals -8. So it's an absolute value equaling a negative, and there's no way that that can happen, so it's no solution. Okay, so which graph represents the compound inequality x less than -32 or x greater than 24? So since it's an or, we're going to do the union of both of them. So we have x strictly less than 32, so we need an open circle on -32. So we've got a closed circle here, so we automatically know that that's not going to be our answer. And then looking further down, we've got an open circle here, but it's shading right in between. This would be an example of an and. And what do we have? We have an or. So I know that that's not going to be an answer either. So going on further down, I go here. I am at -32, but it's closed, so it's not that one as well. So it needs to be the last one. So I'm at -32, open circle, and I'm shaded to the left, which is exactly what I need here. So I have an open circle on 24, which is what I need, and I'm shaded to the right. So my answer should be letter D. Solve the inequality, then graph your solution. So here we have a compact inequality. So I'm going to go below and I'm going to solve it all at once. And looking at this, I don't divide first. I'm going to add. I'm going to move this -4. And how do you move a -4? You move a -4 by adding 4 to all sides. So I get -4 is less than or equal to 2x less than 8, because these cancel. That's the whole point. And now I need to get rid of the 2, so I'm going to divide all sides by a +2, which means I don't flip the signs around. So I get -2 less than or equal to x less than 4. So I'm going up to look at my graph. I need a closed circle on -2. So all of these have closed circles. That's on -2, and that one's on -2. So right away, I can eliminate these two. And this one right here says it's going to be less than 0, and I know it should be less than 4, which is this one. And it's an open circle on 4, so I know that C is going to be my answer. Alex saved $65. He has already spent $25. He plans to spend $8 on a movie ticket each month. There is my rate of change. For every movie ticket he buys, for every month, he's going to spend $8. So this number is going to get our variable. Which inequality represents the number of movie tickets he can buy? So I know what a lot of you were thinking was to subtract $25, but we're actually going to be adding it all together because it's about how many he can actually purchase. So we're having an $8 times every movie ticket. So that's where the 8 times T comes from. And then we've already spent $25. So to this amount that we're spending, we're going to add $25 more because of this part right here. He already spent that. And then he has a total of $65. He can't go over this amount. So it's going to be less than or equal to 65 because that's the most that we can spend. So again, going over everything, 8 times t, the 8 is attached to the t representing tickets, because every time he buys another movie ticket, he spends another $8. And then we're adding to that the $25 that he already spent. So that would have been my y-intercept. At 0 movie tickets, he already spent $25. And then it says write an inequality, which means we need to use an inequality sign. And since he only has $65 to spend, it's got to be the less than sign because we can't go over 65. And we make it less than or equal to because he can spend $65. So the answer for this one was A. Solve each linear absolute value inequality and graph the solution on the number line. So this one's just a little bit trickier because it's got a number out in front. I need to isolate that absolute value first. So we have 3 absolute value x plus 4 greater than or equal to 9. So remember, this is multiplication. And how do we undo multiplication? With division. I'm going to divide both sides by 3, and I get absolute value of x plus 4 is greater than or equal to 3. It's a greater than sign, so I know it's a great or situation. So it's exactly what you see or the opposite of what you see. So let's split this into 2 inequalities. Exactly what we see without the absolute value is x plus 4 is greater than or equal to 3. Or now the opposite. And remember, we always write exactly what we see in here. We never change the signs inside of the absolute value. We change the inequality and we can change the answer, but that's all we change. And then we need to go through and subtract 4 from all sides. And that leaves me with x is greater than or equal to -1, or x is less than or equal to -7. So we can go up and look up here. We have x is greater than or equal to -1. So here we have a closed circle and we're going to -1. And we need a closed circle on -7 and going to the left. So that would leave me with D. I know C is not my answer because it's in compact form. I know A is not my answer because of the open circles. So it would just basically be between B and D. And since it's this situation here matches it perfectly, we know the answer is D. Classify 3x squared. Well, it's got the x squared up there, so it's a quadratic function. What is the solution to the linear absolute value equation? So this one's a little bit trickier. What we need to do is isolate that absolute value first. So let's first start doing that. 102 equals -11, absolute value x plus 16, absolute value closed, minus 19. So the first thing we need to do is add or subtract, right? Before we multiply or divide, we need to add or subtract. So let's move that -19 over to the other side by adding it to both sides. I would get 121 over here equals -11, absolute value x plus 16, absolute value closed. And then now I need to get rid of this -11. How do I get rid of a -11? I cannot distribute him in. That is a no-no. You cannot do that. So this is multiplication. -11 times this absolute value. So how do we get rid of multiplication? With division. So we need to divide both sides by -11. And when I do that, I get -11 on the left because 121 divided by -11 is actually -11 equals absolute value x plus 16. And we should stop right here because an absolute value cannot equal a negative number. So after 2 steps, we can see that this problem is going to be no solution because we cannot have an absolute value equaling a negative number because the absolute value is talking about the number's distance from 0 and distance cannot be negative. Okay, here are my extra credit situations. I thought that they were both pretty fairly simple. Not too many of you got them both correct. Remember, whenever we have an absolute value situation, we need to split this into 2. So let's start doing our little branch off into 2. And I have x plus 9 equals 2, or x plus 9 equals a -2. And now I'm going to subtract 9 from all sides. And I get x equals -7, or x equals negative 11. So those were my two answers. You should have gotten a +1 for either one of them, and if you got both of them, you got a +2. All right, this one was just asking what number would you add to each side of the inequality to solve this. So this was just asking you, how do you begin solving this problem? And we've done this a lot today. We do not divide first. We've got to look at this number sitting out all by itself. We're not going to move him. He's already away from the end, so we're going to leave him here. We need to move this number, and how do we move it? Well, he's a subtraction, and how do you get rid of subtraction? By adding. So we're going to add 14.4 to both sides. And that's what it was asking, is what number would you add to each side? I would add 14.4 to both sides. So if you got that right, you got a bonus point. If you went on even further and ended up solving it, right here we would get 27.4 less than 4n. And then some people actually they divided it by 4, and they got the answer 6.85 is less than n. And I actually gave a bonus point if you got down to there for just going above and beyond and solving it. So you got a bonus point for having this answer, and you got a bonus point for that one. All right, guys, thanks so much for watching. I hope this helps. Bye.